We're now going to take a look at the equation that we use for convection calculations, and this is referred to as being the convection rate equation. And if you recall, when we looked at conduction, we had Fourier's law. Well, for convection, we have a similar equation, and it is called Newton's law of cooling. And so this is the equation that we use for a lot of the convective heat transfer calculations, pretty much everything that we're doing. Again, on the left-hand side, we have Q, and that is going to be our heat transfer rate in watts or joules per second. And then on the right-hand side of the equation, we have H. That is our convective heat transfer coefficient, and that's really where the bulk of the effort is going to be, is determining what that value of H is. We have the wetted surface area, the contact between the fluid and the solid. And then we have the wall temperature minus the free stream temperature of the liquid. So this is Newton's law of cooling. Q is our heat transfer rate. H is the convective heat transfer coefficient. A is going to be the surface area. And then T wall minus T infinity. So we'll be using this equation, and like I said, determining H is going to be the biggest battle that we have when we're dealing with convective heat transfer. There are many different empirical relations that we'll be using and for determining the value, and we can then apply it for engineering calculations. And so sometimes the unknown might be the wall temperature, sometimes it might be the rate of heat transfer, might be a sizing problem, different things like that. That is Newton's law of cooling. What we'll do in the next section